many times have I won?
Yeah.
4.
Impressive. Impressive.
2 London, 1 Oslo, and 1 Portugal.
Very impressive. So just before we get going again, there we are. I'll stop YouTube from talking to me. So next month, don't forget, we've got Dylan Beattie and Layla talking of PubConf. And then we've got over on Knox IoT, we've got John Skeet and Dave Stapley on the 12th of August. Tomorrow is DevOps Knots with Sarah Lean and Manuel Pais. And I forgot to mention, it's the Virtual Azure Community Day tomorrow as well. I think it starts at stupid o'clock in the morning at like 3 a.m. And I'm giving a talk at 1 p.m. BST on .NET Core on the Raspberry Pi. So if that's half interesting to you, then do feel free to check that out. But yeah, that should be a good day of .NET talks and Azure talks tomorrow. So do check that out. And with that, we will get going with Mark Rendell's talk. So thank you very much, Mark, and over to you.
Thank you very much. So I'm hoping everyone can see my slides there, and I will move people over to that side. So yes, welcome to Write Code That Writes Code with Roslyn. I'm Mark Rendell. I am currently working with Gibraltar Software, publishers of Loop and VistaDB and Visual Recode, which is my thing that I made. And that's where I learned all this Roslyn stuff that I'm about to share with you. You can reach me at that email address, or the best way to get me generally is to ping me on Twitter at Mark Rendell. Yeah, I'm happy to answer questions or share helpful information around there. So hopefully everybody knows this already, but what is Roslyn? It is fundamentally where the red and green squiggles these days come from in Visual Studio, unless you've got ReSharper installed, in which case they come from ReSharper. But Roslyn is the C# compiler platform. It's also the VB.NET compiler platform if people use VB.NET. For the first however long it was in .NET, C#'s compiler was written in C++ and VB.NET's compiler was written in C++. But everybody knows that it's not a proper programming language until the compiler is written in itself, which is fun. But TypeScript's compiler is written in TypeScript, and C's compiler is written in C, and now C#'s compiler is written in C#. But rather than just go, let's rewrite the C# compiler in C# and rewrite the VB.NET compiler in VB.NET, they thought about it and they architected a whole compiler platform. So everything that they built is packaged up in NuGet packages and has open APIs, and you can download it and include it in your code and use it to do funky, cool, fun things. And we're going to look at some of the funky, cool things you can do and how they work over the course of this talk. And as I say, I learned it because last year at Build 2019, Microsoft were talking about .NET 5 and how that was going to be the next version of .NET after .NET Core 3.1. I still think they should have gone to .NET Core 95, but you know. And they said .NET 5 is the unification of all the .NET platforms, .NET Core and Mono and Xamarin. And people went, and .NET 4? And they said no. And one of the things that's not coming over is WCF, Windows Communication Foundation. And there was much wailing and gnashing of teeth. And I suppressed my instinctive urge to mock enterprise programmers for using WCF because Microsoft told them to. And I thought, I've looked at gRPC a bit, and gRPC, you have an interface definition file which declares what your service is going to look like, and then you have the code that implements it. And with WCF, you have an interface definition file, which is basically a C# interface or a C# class with some attributes on it. And then you write the implementation code for it. So there's not actually a huge, and I thought, I wonder if you could use that Roslyn thing to look at all the classes in a WCF project that have got service contracts and data contracts and operation contracts and things, and just rewrite it as a gRPC application. And so I spent sort of about a month hacking around with some command line code and learning Roslyn, and it turned out that you could. And then I suppressed my urge to make it open source and put it on GitHub, and decided to package it up as a Visual Studio extension and sell it for lots of money instead. And I'm not sorry, because I've done lots of open source things, and I deserve money. I'm a good guy. People should buy me nice things. Anyway, but the thing is, I could never have done this without Roslyn, because without Roslyn, it would have been sort of figuring out all the possible syntax of C#, and that just keeps becoming more and more syntax as time goes on. And working with Antler or FS parser, or, you know, it's just horrendous. Whereas with Roslyn, it's a DOM for C# code or for VB.NET code. And so you just go, hey, Roslyn, pass this, and then give me a DOM back. And just like you can go querying through an XML document or an HTML document using the XML DOM, you can do the same thing with your C# code using Roslyn. And it's really, really straightforward. And it makes things possible. So I am going to show you how to Roslyn and things you might look at doing with Roslyn to enable you to do funky and interesting things with your own code without using regular expressions. Because if regular expressions can't pass HTML, they definitely can't pass C#. So Roslyn is essentially a bunch of NuGet packages. And the fundamental ones you're going to need is you've got Microsoft.codeanalysis.C#, and that's got everything you need in it to parse snippets of C# from text strings and then work with them as a DOM. But for the most part, you're going to want to be working with projects and solutions, and working with files in projects and solutions. And so you get into workspaces. And so there's Microsoft.codeanalysis.C#.workspaces, which makes C# work interactively with the whole project system. And there's also Microsoft.codeanalysis.workspaces.msbuild, which you can use to load Visual Studio or .NET solutions and projects and work with them. So you have a top-level workspace object, and then it's got a solution object, and the solution object has a tree of project objects, and the projects have a tree of document objects, and then it goes down below that. So those are the two main things. There's also Microsoft.build.locator, and we'll talk about that in a moment. And the other one that comes in quite handy is NuGet.projectModel, which is very helpful for working with things like package references in the projects if you want to find out which NuGet packages your project is referring to and that sort of thing. So up at the top here, we have this concept of workspaces. And if you think of it as a Visual Studio session, Visual Studio is the workspace, or VS Code is the workspace. And the workspace can have a solution loaded into it, and then you can work with that. But the workspace is this top level thing that you can create, and you can load a solution into it, and then you can unload it, and you can load another solution into it. You can't have more than one solution active at a time, but you can reuse a workspace that you've created. And there are multiple kinds of workspace available to you. There's an ad hoc workspace, which you can just go, hey, add a project to this, and then add documents to the project, and you construct it in memory. And that's quite handy for just messing around when you're actually building things. And it's also incredibly useful for writing unit tests for your code that actually will be working with something like MS Build Workspace when it's actually running. MS Build Workspace is the main one. So MS Build Workspace, you can open a solution and you can do things like save changes to a solution and that sort of thing. And that comes from the workspaces.ms build NuGet package. And then there's Visual Studio Workspace. And if you are writing a Visual Studio plugin and you say, hey, Visual Studio, give me your Roslyn workspace, you will get this special Visual Studio instance. And this is actually included in the Visual Studio SDK. And if you want that, then go into Visual Studio Installer and enable Visual Studio extension development workload in the Visual Studio Installer. So you get your workspace and you open a solution into it. And that looks something like this. So let's go back to there. Yeah. So here we can, does anyone else have VS Code and get told about once every half an hour that the Azure pipeline schema has changed? Is it like connected to an actual Azure Pipelines web service somewhere and they're just doing continuous deployment and updating it every half an hour? It seems to happen a lot. Anyway, so here we can see that we have just a regular .NET Core 3.1 console application. And the first thing I'm doing here is I'm using msbuildlocator.register defaults. And this is coming from this microsoft.build.locator package here. And what this does is it says the Microsoft.codeanalysis.workspaces.ms build package is going to bring copies of Microsoft.build.framework and various other like MS build assemblies with it. And those might not be the right ones for what you want to work with. Because what you want to work with might be Visual Studio's version of MS Build or a particular version of the .NET SDK. And so this MS Build locator.register defaults says before you go off and load the packages that came with this thing that I've made that came from NuGet, find this machine's MS Build instance and use that. And so you know that you're working with the right one. And this is kind of fun. If you write Roslyn code in a .NET 4-point-something console application or any kind of .NET 4-point-something application, msbuildlocator.register defaults will find the MS Build under C program files, Visual Studio, wherever the hell it keeps MS Build. If you do it in a .NET Core application, it'll find the one under C program files .NET, which is the .NET, the core version of MS Build. I'll come back to that in a moment. And then we can say msbuildworkspace.create, which is a nice static method. And then here we say load metadata for referenced projects equals true. And the reason we do that is that every bit of sample code I've ever seen has that in there. And so I do it. I don't know what would happen if I didn't do it. And frankly, I'm scared now. And so I'm just going to keep doing it. It seems like a good idea. Then we are going to set up an event handler here. Workspace.workspace failed. So sometimes, like when in Visual Studio you load a solution, it'll go, this isn't working, everything is terrible and wrong, and you don't have this particular thing installed or this extension installed, and I can't load this solution, and you get lots of messages. And with doing this in code with Workspace, the Workspace failed lets you get those messages, and it just calls this event handler down here. And if I want to see them, then I can do something with them, or I can write them to my logs or whatever it is I want to do with them. And then I just say var solution equals await workspace.open solution async, and I'm just passing in the solution name here. And that's it. I have now loaded and interpreted and parsed and understood an entire Visual Studio solution just with 1, 2, 3, 4, 5 lines of code, one of which is optional and one of which I don't know what it does. So that's quite impressive. So what this is going to give us once we're done is a workspace hierarchy that looks like this. You've got the workspace at the top, and then solution, there's a current solution property, and then a solution has a collection of projects, and a project has a collection of documents. And some of those projects might be C# projects, and some of them might be VB.NET projects, and some of them might just be solution folders, which are a kind of project. And then in the projects, there are all the documents, and some of those documents might be C# documents, and some of them might be embedded resources and so forth. And so you need to make sure as you're going through your projects and your documents that you're specifically looking at C# ones, or ones that you can understand with Roslyn. So quick note here. So MS Build, you set the MS Build environment with MS Build Locator. I kind of recap this in the slides, because then people say, hey, can you send me the slide deck? And I go, yes, it's useful, rather than, okay, but it's pictures of kittens. So we use MS Build, Microsoft Build Locator, and we do register defaults, and that either gives us an MS Build workspace, or we have a Visual Studio workspace. And then here is this thing with the badness. MS Build Workspace, so if you have a .NET Core application and you try and load in a Visual Studio solution, which has got the old style CS proj before Microsoft kind of trimmed it all down and took all the hint paths and everything out, then MS Build Workspace can't load it, because one of the things it does is it tries to load the MS Build Locator and MS Build Workspace, try to load the task assemblies that are referenced from those CS proj files. And if you've got a .NET Core application and it tries to load the task assemblies from a .NET 4 point something application, then it will load the assembly and then it will go, I don't understand, and you'll get loads of error messages. So if you want to write code that works with old style CS proj files, you have to write it in .NET 4.7.2 or .NET 4.8, which is really annoying. And I don't know if it's something that they're ever going to fix, so you might be able to do it with .NET 5. I get the impression they're not particularly interested. So yes. Okay, so we've got our solution loaded, and now we want to start understanding C# code and doing clever things with it. And the first point on our path is syntax trees. The syntax tree is effectively the DOM that I was talking about, the document object model for C# code. I'm going to keep saying C# code. This does apply to VB.NET code as well. You just use, it just gives you different things back. It's basically transparent. But your syntax tree, you have a syntax tree, which is the abstract syntax tree that you can't actually do an awful lot with. And then you have syntax nodes, and a node is part of the actual DOM that you can traverse. And a node has a parent node, and it has child nodes, and you have descendant nodes, and all those sort of things that you would expect from a document object model. And then you have syntax tokens, which is things like actual keywords or identifiers or literals or whatever those might be. And you have syntax trivia. And syntax trivia is things like comments and semicolons and white space. Anything that's not actual code is trivia. Braces are trivia. So not all trivia is trivial. So if you like braces, if you don't have the braces, then it will change the meaning of your code, but they're not actually in there as tokens. They are called syntax trivia. So you will get back a tree, and you'll get a root node, and then that root node will contain lots of child nodes, and it can be very scary trying to work out where these things are, and how to find the thing that you're looking for. And so one of the things that you get if you install the Roslyn SDK tools into Visual Studio is a plugin for Visual Studio called the VS Syntax Visualizer. And this gives you a window that sits alongside your code editor window and shows you the stuff that is the equivalent side. If you've ever written a WPF application, then A, I'm sorry, I hope you're feeling better, and B, you know, the thing where you can sort of enable the crosshairs, and then when you click on something in the WPF application, it jumps to it in the tree. So VS Syntax Visualizer does that for Roslyn. When you click on a line of code in the editor, it jumps to the thing that represents that code in the tree. And so if you're kind of going, oh, how would I pass a method that calls entity framework and then returns a property off that, you can just write it in a Scratch sort of CS file and then spin up the VS Syntax Visualizer, and you can actually dig into it and find the thing that you should be looking for, which could be like an invocation expression or a simple member access expression or something like that. Okay, so yes. Right. Once you've kind of found out what's going on in there and so forth, you need to actually know how to navigate through the syntax in your code. And this is where I'm going to start getting into code examples. So there are two main ways of navigating through the code. And the first one is trusty old link. So just like you can with XML documents, or if you've used AngleSharp or something like that, you can say node.descendantnodes.oftype class declaration syntax, and then that will give you all the classes that have been declared in that particular document. And if you want to traverse back up the tree, you can say something like node.firstancestor or self, and it will look at itself. There's no first ancestor, it's always first ancestor or self, but it will look back up the hierarchy and say, give me the first thing that matches this syntax type. And there's a whole kind of class hierarchy of these syntaxes. So class declaration syntax inherits from type declaration syntax, which also has interface declaration syntax and struct declaration syntax and all these sorts of things. And so if you want to find all the type declaration syntaxes, you can do that as well using the link API. And so let's dive in and look at some actual code in this junky little demo that I've written. So I've got a syntax query demo here, and I'm going to jump over to this bit of code. And you can see here, so I pass in the solution. And this is what I've got from workspace.OpenSolution here, OpenSolution async. There's a lot of async in Roslyn. Everything is asynchronous, mainly because it's designed to run in the background in Visual Studio, and they're trying not to block the UI thread with varying degrees of success. So we pass in the solution and we say, for each document in, go through the projects and select all the documents in the projects, and then get the syntax root from that document. So this method here, if that document is a C# or a VB.NET document, it will give you a syntax root. If it's not, it will just return null rather than throwing an error. We could, if we wanted to check this up front, we could say if document.supports syntax tree or supports syntax model. And if this was proper code, I would already have put that check in there somewhere, because checking that Boolean to see if it does support it is a lot quicker than awaiting get syntax root async and then seeing if it's null. So I just put a where on here saying documents.where supports syntax model. But here I'm just going to say get the syntax root. So this is giving me effectively the top level DOM. If this were linked to XML, this would be the X document. And then I can say for each type declaration syntax in root.descendantnodes.oftype, and you see I've got base type declaration syntax here. So this will give me all the types. And then I can say, give me the namespace declaration syntax. So I'm going from the type declaration syntax, which is somewhere below me in the DOM. I'm going to come back up again, looking for a namespace declaration syntax to get the namespace. And then I now have two nodes in this tree. So I have a type declaration syntax node and a namespace declaration syntax. And the type declaration syntax has an identifier property, which is a syntax token. So remember, that's the sort of basic unit of syntax. And that identifier has some text with it. And so that will be the type name. And then namespace declaration syntax has a name property, which is a name syntax, because this is not an identifier in the same way. It's kind of metadata. It's not identifying an actual thing that actually exists. So this gives us a name syntax, and then name syntax we can just pass to get to string, and that will turn that into the right syntax for us. And then here I can just write that out, namespace.typename. And so if I just save this and I move across to my demo code here, and I can run this, and I know what I'll do. I'll open the sample up so you can actually see that. That'd be good, wouldn't it? So here's my sample. It's a console application, which has got a static void main, and then there's a class library with a greeter class inside it, and it does interesting things like that. And this is plenty to introduce Roslyn in an hour. Okay, so from that we can see that my console application found sample.program and sample.library.greeter. So it found those two classes in the project along with their namespaces. And this works quite well when you're just finding your way around the DOM and writing some exploratory code, and going off and sort of spelunking through your code base to find things. But you get to a point where this can get quite complicated. So if say you're going through and you want to find everything in a class, and then you want to find all the methods of that class and the constructors and the properties and the fields and the event handlers and everything else, you tend to start thinking there must be a better way than writing all these link queries and looping through all these nodes and so forth. Surely there should be something like the visitor syntax for this, like there's visitors for XML DOMs and that sort of thing. And there is something like the visitor syntax. There is the CSharpSyntaxWalker. CSharpSyntaxWalker actually derives from CSharpSyntaxVisitor, and they're both in there, but CSharpSyntaxWalker is the one that you want. And the syntax walker, there's a VB syntax walker as well, over on that side of the fence where the grass is a weird yellow color. But the CSharpSyntaxWalker, you have a bunch of methods which you can override for almost every kind of syntax that could be in the document, that you can say, when you find one of these, call this method. Okay, and so we here have visit class declaration, and it will give us the class declaration syntax node here, and we can do whatever we want to do, and then we can call base.visit class declaration node in there. So if we go back to the sample code here, not the sample code, go away, you're the wrong Visual Studio. Okay, so we have a syntax walker demo here. I'm going to take this out and we'll go over to this bit of code here. And so this, we've shortened the list code quite considerably. We create a walker of type list types walker, and then we just say for each document in all the documents, get the syntax root, and then walker.visit root. And if I go to list types walker here, you can see when we've got a class declaration, we write that out here. And if we've got an interface declaration, then we write that here as well. And then we've just got this static method down here. And this does basically exactly the same thing, but it does it a lot more efficiently. And it does it without you having to write all those link queries with of type and so forth. And it does it in one pass. So if you are running link queries over and over again on root.findDescendantNodes or descendantnodes.of type, you're essentially passing through that entire syntax tree over and over again. If you use a syntax walker or a syntax visitor, it's doing it once and calling your methods at the point when they're hit. So this is a lot more efficient for code that's actually running in production. And one of the things that you're going to, if you get into writing a lot of Roslyn code, is writing analyzers. And analyzers are running while you type. And so you want these things to be performant. You do not want them to be consuming loads of memory and taking loads of time. So a syntax walker is a much more efficient way of dealing with syntax than all those link queries. But the link queries are great for writing console applications to figure out where the hell the syntax is that you're interested in the first place, okay? If you're wondering why I keep looking to the left, it's because you're all on a screen over here. Okay, so the PowerPoint's here. I've got a little screen here which has got the code on it, and Twitter's on there, so I can make sure nobody's maligning me on Twitter while I'm streaming live on YouTube. Yay, not yet. So yes. So there's a huge amount of stuff in the syntax tree and in syntax nodes. Literally everything you could think of in C# is represented in there because of course it is, it has to be. But trying to understand what's actually going on in your application, what it means, is quite challenging just from the C# syntax walker. So say you've got somebody's used the class color. Now, just from having a syntax node with an identifier that says this is called color, it's not going to tell you what namespace that class comes from. And so you can look back up the syntax tree and you can find all the using statements that are imported, and then you can analyze those and go, well, which one of these namespaces has got color in it? And then, okay, so it's probably system.drawing.color, or it's system.html.color, or wherever else color exists. But you would be writing a lot of code. And the people who were creating Roslyn would also have been writing a lot of code over and over again. And so they came up with something to make it a bit easier to understand what all that syntax is actually doing and what it means. And that is semantic models, which is the whole other half of Roslyn. And semantic models are what make it really approachable and usable and not this is what turns it into a power tool rather than a little hand drill that you're supposed to tunnel underneath Berlin with. So semantic models let you say, hey, I've got a syntax tree and I want to find out what all this stuff means. So what are these classes? What actually is that class? Where does it come from? What's its namespace? That sort of thing. And so we have this idea of compilations and models. And so this project, that project that we get from the solution, if the project supports compilation, we can say, hey, project, give me your compilation. And that compiles all the C# code in the project and gives it back to you as a kind of in-memory model of what the code will actually look like when it's running. And then for any syntax tree that you get from a document, and this can be at any level within the syntax, you can say, hey, compilation, give me the semantic model for this, this syntax. And that semantic model will provide a bunch of other stuff for you. And the main thing it provides is symbols. So this model that we've got here is going to be the model for a document. So it's a unit of C#. that we've passed in, and it's probably some using declarations and a namespace declaration and then a class, assuming that you've got one class per file. Otherwise it could be as many classes as you've got in there. That model we can then go to get symbols, and we can call very simply into that and say, hey model, I've got this identifier name syntax here like greeter. Give me the symbol info for this identifier. And then that will give us an iNamed type symbol, which has useful information like base type. So iNamed type symbol and symbols generally are starting to look like the reflection data that you can get in .NET at runtime. So like get type and get method and all that sort of thing, except you get it without needing to build and run the application. And you also have get type info. So if you have an expression syntax like var a equals 42, then type info, you can pass that whole expression in and it will say the type of this expression is integer. And then you can go off and go, well, what is integer and what can I do with integer and where does integer come from? So let's jump back into the code here and we will take a look at symbol demo, which does things a little differently. So symbol demo, we have gone back here to doing this using a link query, but you can create a model. So you can do this await compilation.get semantic model thing, and you can pass the model into a syntax walker or a syntax visitor, and then you can use the model inside the visitor to do this useful stuff here. But basically, all this stuff here is just like it was before, except here we're saying, we want to say if model is null, continue. But yes, so we're saying, give me the syntax tree, give me the semantic model for that tree, give me the root from that tree here. So syntax tree is the tree and root is the syntax node at the root of the tree. Okay, so X document, X element. And then we go through and we get all the base declaration syntax, but then we can say, hey, model, give me the declared symbol. So because this is a type declaration syntax, we can say, what symbol is this declaring? And we can say, give me the declared symbol that this syntax is for. And we're assuming that it's, or checking that it's a named type symbol. It will almost certainly be an iNamed type symbol, but it can potentially be other dodgy things like error type symbol. Because Roslyn is designed to run with code as you're writing it, it's very good at coping with code that wouldn't actually compile. And so sometimes what you get back is an error type symbol where it gives you as much information as it can, just not all of it. So we check here to make sure it's an iNamed type symbol. And then here we can say, write out the symbol's type kind, which will be either class or interface or struct or something like that. And then we can say symbol.containing namespace. So we don't have to go passing through the syntax tree to try and find things anymore. The symbol has got all that information in there itself. And symbol.name, which is whatever the class is called. And now we're into a symbol, we can say, hey, give me the members of this symbol. And so you can't do get methods and get properties like you can with the type class at runtime, but you can say get members and then of type iMethod symbol, and that will return you all the public, private, static methods and also the constructor. And with the method symbol, you can also check to see whether it's implicitly declared. So what the semantic model will give you at this point, because it's sort of semi-compiled it, if you've got a property, then this list of members will actually include the automatically generated get and set methods for that property. And various other methods that are generated by the C# compiler by Roslyn as well, and you generally don't want to see those. So you can check to see whether the method is implicitly declared here. And then we'll just say if it's not implicitly declared, then we'll write it out here like this. So if I now run this code, you can see that this in this solution finds a class called sample program, which has got a method called main and a method called ask name. And we got a class sample library greeter, which contains a constructor and a method greet. And there is a huge wealth of information in here. So from this symbol here, I can get all this useful information. So I can get all the interfaces that this symbol implements. And that includes, so if I am implementing an interface and that interface implements iDisposable, that will automatically be included in this all interfaces thing here. I can get associated symbols. I can get the base type. I can get the containing assembly. And if it's got another, if you've got a nested class, then it'll say this is the type that contains this class. I can get the, these are things that for some reason are properties. And then there are other things you can get, like attributes, which is a method. You can say, give me all the attributes that this type has. You can say, give me the .comment XML. So you can get comments and information and type arguments and all sorts of stuff. So once none of this can come from the syntax, you have to go digging around going, give me its parent syntax, give me sibling syntax and all this sort of stuff. But as soon as you get this semantic model and you get your symbols, then suddenly it's become just like working with reflection at runtime, really quite straightforward. And you know, lots of lovely IntelliSense for you as well, even in Visual Studio Code. I don't actually use Visual Studio Code for day-to-day programming. I use it for presentations because it's nice and clear. I try and do most of my coding in Rider these days. And then I decided I was going to write a Visual Studio extension. And guess what the one .NET thing you can't write in Rider is? Visual Studio extensions. Okay, so that gives us a more intelligent, less scary view into the syntax. So we got a solution, we get our projects, we go, hey projects, give me the documents, hey document, give me your syntax tree, hey semantic model, give me what this syntax tree means, and now I can dig around in it and find what's going on and everything else. Okay, so if we put these things together, then we can write something that actually goes and digs through our code base and finds maybe something more useful. We could find all the types that are used anywhere in the code base. And by using syntax trees and syntax walkers and other bits and pieces, it's almost like I just came up with a completely arbitrary set of things to do for demos. Okay. So here in list all types, again, we're passing in our solution. We're going through our projects. We're going to say, get our compilation. We're going to get our semantic for each of our documents. We're going to get our syntax tree and our semantic model. And we'll get the root of our tree. And then in our get types down here, so we'll say get all types for this syntax node with this semantic model. So if I go down to here, you can see that we've got our named types is all the identifier names in anywhere in our code, where we're going to say model.getSymbolInfo .symbol. So getSymbolInfo returns a symbol info object, and that has a .symbol property which is nullable. So if it can't find the symbol info in the model, then that will be null. So if we say of type iNamed type symbol, then it will make sure it doesn't return any nulls. And then we can also go through and we can check expression syntaxes, and we can call model.getTypeInfo.getType. And you'll see here that model.getSymbolInfo returns iSymbol get type info returns iType symbol. And from both of those, we can derive down and get iNamed type symbol. And then we can push both of those together and add them to our set of types here using namespace qualification like this. By the way, this containing namespace, these are nested. So containing namespace as a symbol, it's an iNamespace symbol. It also has a containing namespace symbol, and that has a containing namespace symbol. So if you've got nested namespaces, then you need to go sort of spelunking up them. It's just when you call to string on containing namespaces, it turns it into dotted. So it works nicely in string interpolation. So if we go back to our command line here and run this code against our sample solution, and you can see there that these are all the types that are used anywhere in our application. So we've got Boolean and char and console and int, string, void, and also we've got assembly company attribute and configuration attribute and so forth, because the documents that are getting returned from the project also include the magic C# documents that are generated into obj/debug while you're working on stuff, which is all sorts of fun, because you do not want to be changing things in auto-generated code. In a regular .NET old .NET 4 application, this would be an assemblyinfo.cs, but that's now auto-generated by the project system, so you don't have to worry about it. So we're about to have a look at that as well, because the next step is rewriting code. And rewriting code presents a whole bunch of challenges. And the first of these is immutability. So in Roslyn, some things are immutable. And if you change, or you can't actually change an instance of like a syntax node in Roslyn, you can say, give me a copy of this syntax node with this thing changed. So syntax nodes are immutable. And the list of things in Roslyn that are immutable is basically everything. And I'm not kidding. The only thing in Roslyn that is not immutable is Workspace. And that's what Workspace is basically for. Solutions, projects, documents, syntax nodes, everything else is immutable. So if you change a syntax node, then your solution that you're holding somewhere else is no longer the current solution. There is now a new solution, which has, yes, there's a new document and a new project. The whole thing is immutable, basically because it makes everything thread safe. And you never get two things racing to update the same node at the same time, because that's not a thing that can happen. God knows how this doesn't drive the garbage collector mad. They did some clever things, and I think there's a lot of caching and pooling going on in there somewhere. Excuse me. But this makes life interesting, because if you think about it, if we're going through our code here, using something like node.descendant nodes.of type, and we get a name type symbol here. If we want to change something in that, then suddenly that entire syntax tree is now garbage, and we've got a new syntax tree which includes the node that we changed. And again, and again, and again. So if you want to be looping through all the code in a C# document and applying multiple changes to it, then it's a real struggle when you start thinking about how you would do that, when as soon as you've made your first change, the rest of the syntax tree that you were looping through is now not the one that you are using anymore. And actually, if you change one of those nodes, you'll create yet another copy of the syntax tree. So now you've got three syntax trees. You've got the original one that you made one change to, and another that you made the next change to. And so rewriting code in Roslyn is actually quite tricky. And again, to make life slightly less hellacious for us, the team created the C# syntax rewriter. So the rewriter is effectively like the walker, except it allows you to make changes and it takes care of keeping which document is current and which node is current and which syntax tree is current and everything else. It handles all that for you. So you can say, hey, call this method for every node that matches this, and I will return the node to replace it with or to rewrite it with if it needs rewriting. Otherwise, I'll just return the original. And then the very, very clever Roslyn people behind the scenes take care of actually making sure that all those changes end up in the same place on the same document. So we could rewrite things with syntax node.replace node, and actually within a syntax rewriter we can do that. But if we dig back into the code here, and we'll just, now here is an insanely useful example. This is going to find all the strings in the solution and add to upper invariant to the end of them. So here we're pretty much the same thing here, except for each document we're going to say, give me the document, give me the thing here, give me the model, create a new string literal upshifter with that model, and then upshifter.visit. And you see here we've got our root that we got here, and this gives us back a new root. So this gives us back a new syntax node. Excuse me. And then we can say if something has changed. So if nothing has changed, those will literally be the same node. If something has changed, then we'll add one to our count here. And we actually have to say, right, so our solution now becomes the solution that we had up at the top here. So we start with the current solution. We're going to create this new copy of the solution with the document syntax root for our document ID, which is consistent, set to this new syntax node that we have created here. So we literally created everything from the solution all the way down, saying that we're going to create a new project, which is a copy of the old project, but with this document being this document, which is a copy of the old document, but with this syntax node, which we just made from our string literal upshifter here. When I first started working with Roslyn, I kept forgetting this because it would take me about 2 days to figure out how to actually do something. And by the time I'd figured out how to do it, I'd forget the solution was immutable and that I had to do this. So yes. And then once we've done all of that stuff there, we say if the solution has changed, then we can call workspace.tryApplyChanges with the solution. And that basically says, if the solution that this started from is the workspace's current solution, then save all the changes and refresh it. And this is what we're now working with. So the last thing to do is to jump into string literal upshifter. So here, our semantic model comes from the project level. And so we can, no, our semantic model comes from the document level. Compilation comes from the project level. So we create a new one of these for every document, and we pass in the semantic model for the document. And then in here, we're just saying visit literal expression. So actually, we're not going to upshift all strings. We're just going to upshift literal strings. So quote, something, 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 quote. So we say visit literal expression syntax node. And we say, give me the type info for this node, which will come back as an I-named type symbol. If the type's name is string, well, this could be string. This could be an inventory system for a factory that makes string. So we want to make sure that we're not going to add a lower invariant call to the wrong thing. So we're going to say type.getMembers, and then we can actually use name of here, which I quite like. So I can go, give me the members that match the name to upper invariant. and we'll just check to see if the first of those is a method symbol. So if it's a type that's called string and it's got a method called toUpperInvariant, we're probably good. And now we can use Roslyn to generate code. And so here we can say syntax factory, I want to generate an invocation expression. So this is a method call basically. And this invocation expression, I have to give it the member access expression. So I'm calling this method. So the member access is the method. And so the syntax kind here is a simple member access expression, which is basically dot, right? And then the node is this node we've got up here. So this is, we're calling, getting the toUpperInvariant member off this node here, which is a string literal, and a member access expression says dot toUpperInvariant, and then basically invocation expression says put the two round brackets at the end of it. So if our literal expression fits all of this, then we're just going to return this new syntax that we've created here using syntax factory, and that will replace the node in the original syntax tree. It contains the node that it's replacing, and that's okay because nothing below this node is going to get changed by this this particular process. So we know that everything below that node is okay, but everything above the node is now dead because something changed. Okay, so if I go back to my code here and I run this and we run it again, and we get one changes applied, and we go back to here, and you can see my absolutely ridiculous code here has now added .toUpperInvariant onto the end of this method here. Okay, so where it hasn't added it is here, and I don't know why not. Possibly I just didn't go through all the projects or something like that, but you know, previously, so the last time I ran this demo, this actually went off and found all those automatically generated assembly info files and added toUpperInvariant to all the version strings and everything in assembly info, which is bad. And so I added some code in here to just check whether the code that's been so when it gets the syntax root.getLeadingTrivia will give you any comments that exist at the start of the file, and then in here I can just say if the trivia at the start of the file is a single line comment or multi-line comment and it contains auto-generated or auto-generated, then ignore it, and that seems to do the job. There's nothing built into Roslyn to do that for you. Okay, so the fun things you can do with this, well, the main thing you can do with it is write a Roslyn analyzer, and I'm just going to show you one really very, very quickly that I wrote for checking usage of diagnostic source. So diagnostic source is something in .NET that provides a sort of common channel that you can pipe metrics and telemetry and so forth through. And you have a diagnostic listener and you can write things to it. And you can see on this code here that we say diagnostics.write bar, and we create a new anonymous object just to pass data through along with our metric. Now, if nothing's listening on the other end of this diagnostic listener, we've just created an object for no good reason. And that's the sort of thing that makes people like David Fowler and Ben Adams cry, and so we don't do it. So before you call diagnostic source or diagnostics.write, you are supposed to check to see if it's enabled or if anybody's listening, which looks like this. If diagnostics.isEnabled bar, then diagnostics.write bar. And So when I introduced diagnostic source at a place where I was working, I wanted to make sure that everybody was going to use it properly, because we were talking high performance and not wanting GC pauses in trading systems and that sort of thing. So we made sure that everybody would do this by writing an analyzer in Visual Studio, and we shipped it as a NuGet package. So analyzers, you can either install them into Visual Studio as an extension, or you can ship them as NuGet packages, in which case they will just work. And the really nice thing with shipping analyzers as NuGet packages is they work in Visual Studio and in Rider and in VS Code and in Visual Studio for Mac. And if you'll see now, a lot of projects are actually shipping analyzers with their library files on NuGet. So XUnit ships analyzers that can say, hey, you've got this thing as a theory and you've got no inline data, or you've got inline data, but it doesn't match the number of parameters that you've declared on the method, and that sort of thing. And they can actually mark some of these as errors that come up with red squiggles and so forth. So you have Visual Studio templates for these. So these are easiest to write as Visual Studio templates, at least to start off with. And the analyzer with code fix, this one in the middle here, is the standard one that most people would want to go for. This will generate you a library package that you can bundle up as a NuGet package, and it will also create a Visual Studio extension package that includes it that you can put in there as well. Excuse me. Oh dear. So here is my diagnostic source analyzers. So in here, we have got our diagnostic source guard analyzer. So we inherit from Microsoft.codeanalysis.diagnostics. So this is a NuGet package for writing analyzers, which gives you a whole bunch of other helpful stuff. And so most of this is auto-generated by the Visual Studio project template. So we give this our name here. We're saying this is our diagnostic source guard analyzer. It's only just struck me what a bad example this is. So this diagnostic and this diagnostic have nothing to do with each other. This diagnostic is Roslyn analyzers. This diagnostic is the thing this is actually working with. If I wasn't doing this right now, I was actually thinking today, I need to write an analyzer that checks ASP.NET Core action. When you say sort of redirect to action or get the URL for an action, and checks the anonymous object that you create with the root values to make sure that the names of the properties in the root values actually match the names of the parameters. Because I spent 4 hours today debugging and trying to track it down, and it was because I had a mismatch there, and I thought I'm going to write an analyzer to stop that from happening again. So yes, but mostly all of this stuff here is just localizable strings and everything else. And we have a no guard rule and a mismatch guard rule and all sorts of stuff down here. But this is the point where we actually want to do something. We have our analyze node. So this is the method that's going to get called from Visual Studio or from whatever is running your analyzer as a NuGet package or as a plugin. And so from here, we can say, hey, give me the invocation expression syntax from this node context here. Somewhere up here, there's a thing where it says it's for invocation expressions, but but yes, so this will get called if the thing that is being analyzed is an invocation expression, so which is a method call or something like that. So then we can say if the invocation expression is a diagnostic source method invocation, right. And you can see here that our context, as well as having a syntax node, already has a semantic model for us as well. So we don't have to worry about getting that. And we're sharing that with any other analyzers that may be running. And so over here, we have this extension method that gets passed in the invocation expression and the semantic model and the method name, and returns out the argument syntax for the first argument to that right thing, which in the context of our code here would be this bar parameter here. Okay, so we say, is the invocation expression's sub-expression a member access expression? If it's not, then we don't do anything. And returning fast is the order of the day. If the text of that identifier isn't the same as method name, then we're not doing anything with this either. Otherwise, get the symbol info for this expression. If the method symbol, if it's not a method symbol, then return false. If the method symbol doesn't have a receiver type, so it's like a static method or something, then we'll return false as well. If the receiver type name is diagnostic source, or it's diagnostic listener, and its containing namespace is diagnostic, and its containing namespace is system, then that's definitely what we're looking for. And so now we're going to say, give me the list of arguments passed to this invocation expression. And if the first argument is something, so like bar, then we'll pass that first argument back out here and we'll return true. Otherwise, we'll just return false. Okay. And then we can say, okay, so we've checked it's definitely a method on diagnostic listener or diagnostic source.write. Is it guarded? And so here we can say, go back up the tree a bit. So we're going to climb out of this thing and start looking for if statements. Here. And if we find an if statement, and then we can check to see if it's a diagnostic source method on the same diagnostic source, call is enabled. And then if it is enabled, then we can return true. Otherwise, we can return false. So yeah, digging into all the code here. So we get the symbol info for the thing that's being called, and then we get its parent. And if the parent, we will keep going up until it's a method or property declaration. So this is fun. This is a for loop that doesn't do standard things. So we got for var parent equals context.node.parent. Keep going until the parent isn't a method or property declaration. So once we get out of a method or property, then we can stop looking for an if statement because there ain't going to be one. Otherwise, we go back up to the parent. And then we can say, if this isn't an if statement, then just go round and get the next parent. And then we can say, find the child nodes and look to see if the if statement contains, so the if child nodes will be everything that's kind of in the brackets after the if. And then we can say, is it the diagnostic source specification, and get the symbol info and check to see whether it's the mismatch is enabled symbol and so forth. And if we get all the way down to here, then return false because we didn't find it. Okay. And if either of those things match, then we return true. If none of them do, then we return false. And then here we say report diagnostic, and we call diagnostic.create. And we say, hey, this invocation expression that you've given us up here, its location, add the green squigglies in Visual Studio and show this as being a bad thing. And we can specify our diagnostic severity and so forth. so if is enabled was called, then we've checked to see it was called, but it was called with the wrong thing. So it's like in this code here, it might have said if diagnostics.isEnabled foo, then diagnostics.write bar. And so that would give us a mismatch. So we create a different kind of diagnostic for that. And then, because people are still lazy, you create a fix for it. And the fix is add isEnabled guard. And in here, we can use a syntax replacement thing. And this, we don't have to worry particularly about syntax rewriters here, because we know we're only working in one particular location. So we've got a very specific node that we're working on, and we just want to wrap an if statement around it. But even so here, when we register a code fix, create changed solution. So every time you press Alt-Enter in Visual Studio, if you're using Roslyn analyzers, you think about this, it's recreating the entire solution in Visual Studio, and it's throwing away the old one and recreating it. So if you're one of the, you're sort of going down a code file and going Alt-Enter, 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 or Control.Enter, 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 every time you do that, it's throwing out a whole solution. Imagine if they were printed. What would the carbon footprint be? Anyway, so yes, we add our isEnabled guard async here. And this is just going, hey, give me the create syntax factory parse expression. Sometimes using syntax factory to actually build things up just from the raw materials is a complete sod. So syntax factory to parse expression lets you just write the C# in a string, and then it returns it back for you. So I quite like doing that. And then we can create a syntax factory with an if keyword. I strongly suspect that is not doing anything at all there. I might take that line out. There we go. I think that's okay. Then we're going to create an if statement with an if keyword and an open paren token, and then we'll put our isEnabled thing that we created up here, and then we'll have a close paren and with a trailing trivia and a new line, and then we'll indent the expression that was there before by putting in some additional spaces in there, and then we'll apply that. So we'll say, give me the syntax root, and then we'll say syntax root replace node, and then we'll replace the whole solution with that document replaced with that syntax root, and we'll return that back up there. And that is our code fix in our Roslyn analyzer. So that's fun. So to recap that very quickly, diagnostic analyzer is the thing that makes the squiggles. And gives you the messages and lets you block sort of compilation from happening and everything else. And code fix provider is the thing that fixes the squiggles for you and does helpful stuff like that. Now, I am fully aware that this was an incredibly quick tour around things. I mean, I say quick, I've gone like 10 minutes over, but nonetheless. But yeah, I'm hoping I've just kind of opened your eye to some of the things that are possible and made you think, oh, that would stop that one guy on my team from always doing that thing that really annoys me. If I could just put squiggles in his Visual Studio and make him stop. So if you do want to dig in further, the resource I used to learn most of this stuff from was from Josh Varty, Learn Roslyn Now, which is a brilliant tutorial series. It's quite old, but it's still basically up to date. Also, if you go to github.com/.NET analyzers, they've got a whole bunch of analyzers written by various .NET teams that give you great examples that you can crib from. I do have to put the obligatory plug for my product in there. If you do have a .NET 4 application and you're looking to migrate to .NET Core 3.1 or .NET 5 later this year, then please go to visualrecode.com and take a look at that. I am just going to very quickly add in another slide here on the fly, because I'm just that kind of person. So let's duplicate the slide, and then we'll go code, and we've got github.com/Rendell labs/.NET Knots Roslyn demo. And diagnostic source.analyzers. And then we'll just go from here. There we go. Sorry, I tried to put something into this just before, about half an hour before the thing started. I was just putting in an intermission video off YouTube from like Monty Python because I thought it would be funny, and it crashed my machine. My whole Windows box, which is brand new and super powerful, 64 gigs of RAM. But yes, trying to embed a YouTube video in PowerPoint killed it.
Did a big foot come down and crush it?
It was basically like that, yes, yes. So yes, but anyway, so all the code that I've showed you, including those analyzers, is on my GitHub at Rendell Labs / one of those two things, depending on which ones you're interested in. All the code is MIT licensed, and you're free to do what you want with it. And so hopefully that will provide you a good start point. And as I said at the start, I'm on Twitter at Mark Rendell. My email address was on the first slide, and do feel free to reach out if you've got a particular thing that you would like some help with, or if you make something super cool and you want me to go, hey, and show other people and that sort of thing, then that's good too. Apart from that, thanks for listening to me, and I'll see you again soon. Cheers.
Thank you very much, Mark. Really good. Has anybody got any questions? Now before Mark actually dies, John has actually gone, so there's no more questions for John, sadly. But if you've got any more questions for Mark, then do take yourself off mute and ask.
I've got a question, actually. Is there any chance you could work with Pete and his IoT skills to just slap people with a device whenever they put .result into my code?
You totally could.
That would be great if you could just do that.
Yeah.
I'd pay all the money.
Or so one of the things that we thought about doing at one place, so it's the place where we wrote the one for the diagnostic source thing, was we had a weird Slack clone thing that was specifically for financial institutions. It was written by JP Morgan, I think, and then they shared it with some others. But it had an API and you could push stuff into it. And we created a proof of concept, and it is actually possible to write an analyzer that runs in the background in Visual Studio, and you could get it to tweet or to post something to Slack just over a webhook. Just every time they do something wrong and they trigger the analyzer. Yeah, you can. It's .NET. Anything you can do, you can do.
I feel like that would bite me in the bum, to be honest.
Well,
I'll slap you in the bum.
Yeah. But yeah, you could hook it up to if this, then that. You could probably, because you've got audio libraries available, you could probably, every time they do it, get it to go, no.
You could easily go from Azure down to a Pi using IoT hubs or something, couldn't you?
Yeah,
you can do whatever
absolutely.
you like at that point.
Yeah, no, that's it. That's the nice thing about it. It is .NET code. You're not having to learn anything new or C++ or sort of strange new technologies. And yeah, if you can pull in a package off NuGet to do it, then yeah, you can make it do that.
Can you integrate this into your DevOps pipeline?
You can run the analyzers as part of your DevOps pipeline. There's something in MS Build that you do. I can't remember how you do it off the top of my head, but basically you can make it show up as warnings. So the warnings that that you get, or errors and so forth. So yeah. The analyzers can become part of your build process, and it's really straightforward, and it's much easier than writing MS Build plugins.
Has anybody else got any other questions? Everyone's so quiet tonight. They're tired. It's Monday.
Yeah.
People are just leaving instead of asking questions. We put them on the spot now.
Well, we can put something on the spot very quickly. So we've got a little form we'll be sending out this week, which I'll throw into the chat now. Just asking some questions on what you think of the format currently of the meetup, if there's anything you would change, just to give Pete and I a bit of feedback. And I've lost the link. Where's it gone, Pete?
It's here. Hold on.
Thank you.
Oh, I was going to send it to everyone in meeting. There we go.
Ta-da!
Oh.
Yeah, so if you can give us any feedback, that'd be really useful just for the upcoming months.
Hey, one of the things that have been nice to rectify is the drop-off we get, because I think we had 52 registered, but 27 people turn up. So, I mean, everybody's got a reason for not turning up to things, but it'd be nice to make it as accessible to everybody as we possibly can. Yes. But we don't know what that means. It's only you people that know how to do that. So,
yeah. Most of the problem that I have is it starts a bit too early.
Oh, there we are. Yeah, one of the questions in the form is exactly that, I think.
Yeah, with my wife's had to put my son to bed tonight so I could join this. So that's really the problem.
Yeah, I mean, it's a problem for me too. My kids, though, 8 o'clock till 8:30 maybe would be the time. And I mean, starting at 9 is just not going to work for a lot of people, I don't think.
No, sort of 7:30 works for all the other ones that I do. They seem to be reasonably well attended.
Uh-huh.
I think partly also splitting, doing one talk per session, I think will help in the long term, because it's a very long time to dedicate to this in one go.
Yep, that's another question, in fact, in the form.
Oh.
So you've
I'll just fill in the form.
Do that, yeah. But it's good because we're asking the right questions, aren't we? If you've already come on with those two, and the other one.
To be fair, if you just have me on, I'll just talk for 2 hours anyway. So
Well, that's what we used to have when before I became the organizer. We used to do just 1 2-hour talk, which can be a bit much for a lot of people. Just depends on the topic, of course, which is why I split it into 2. But even then, I think now in this remote only world we live in, I think 2 hours is possibly a long time. I'm not sure. I mean, those were 2 excellent talks, where they were quite in-depth talks, weren't they? So sometimes people might find that a bit much if there's 2 in-depth talks, one after another. There's a lot to take in.
The biggest problem I find is, I've been sat at this desk on a computer all day doing lots of virtual calls, and then another virtual call is very draining.
Uh-huh.
It's very different to physically going out and spending an hour or even 2.5 talking with people in real life. It's a very different environment.
Yeah,
you're right. Yeah.
I think you might be better doing talks meet up more often and have 1 talk per meet if you've got enough speakers. It's a luxury you have to have.
Yeah,
I mean, probably in Nottingham of 39 meetups in this one city per month.
Yeah.
Yeah, it does make it a little bit more difficult. I see, Jess, you've swapped webcams. Interesting.
Well, my system's overheated. Everything's died. This is what happens when you sit at your desk from 6:30 in the morning. Yeah, it's just not switching back on again.
No.
Oh dear.
But yeah, Jess is right. Scheduling is difficult for us because even though we're remote, we do try not to overlap too much, and we have got so many quality meetups that I like to be able to go to, a lot of them as well. So, but you're right. I mean, something that did even occur to me is doing a lunchtime meetup. So a shortened one, and I think Jess has put down on there a possibility of having half-hour speaker slots as well. So there's lots we could do, and any feedback from the attendees is going to be key.
.NET Knots brown bag lunch.
Exactly.
Fridays at 12.
And sandwiches to your house.
Yes.
People don't want sandwiches. People want socks.
People.
I don't think I've worn socks or shoes in months.
You haven't got kids, have you?
No. I am the child.
No. Yeah, you put shoes on if you've got kids who like Lego.
Yes. Yeah. Or just squidging in an old carrot that they dropped off the table, I think.
Oh, yes. Right.
That's good. Yeah. So yeah. Yes. Thank you. Go on.
I was just saying I'm going to drop off because I am absolutely shattered. So thank you very much for having me, and I will see you guys around and hopefully in person sometime soon.
Yeah, please. Yeah. Thank you again.
Mark.
Thanks, Mark.
Cheers.
All right.
Really
Cheers,
good
everyone.
talk.
Thanks. Bye.
Cheers. That was awesome. And yeah, thanks everybody for coming along as well. Do remember the meetups we've got coming up. Including mine tomorrow, obviously, and Not IoT on the well, you've got to plug it, and it's an Azure thing, so it's on topic. And then Not IoT with John Skeet and Dave Stapley, that'll be cool. And then DevOps Knots tomorrow, and then Dylan Beattie and Layla Porter the end of next month. So we're avoiding, if we can. I've not actually heard back from Layla, so I'm kind of just put her down anyway. And obviously if anybody who is listening would like to speak, and I know that there are at least 2 or 3 people that I know speak in this group of people, then Jess has just put a link in there. So we have to plug these things. Actually, we're quite lucky.
Probably should do it at the beginning.
Yeah, true.
Not
True.
at the end.
You're right. Yeah, you're right. Although we're in a lucky position that we're actually booked up right through to November, and we don't have one in December because, it would be almost New Year's Eve, so no point. So we're booked for the rest of the year. So, but we do around this time start actively recruiting for speakers for next year. So, do get in touch if you've got talks. Then we'd love to have you. And obviously the spaces are free. So get in there quick before I get the whole of next year booked up again. We've got quite an exciting speaker for .NET Knots, which I'm not announcing yet, in November. But if you know anything about the release schedule for .NET, then you may be able to guess who that is. But we'll announce that a little closer to the time. That should be quite cool. And Jess has put in the chat that her system is overheated, but that's only just come up now, weirdly. So that's testament to how much it's overheated. It's time traveling.
Yeah, I've had issues with my laptop this week. Damn Dell update making my charger invalid. Great.
Annoying.
Oh God.
Yeah, I had a BIOS update and now it won't recognize my charger.
Oh. Probably because it's got too low a wattage or something bizarre.
Yep, it's gone from 60 watts to 90 watts as a standard.
Oh, you. That's them having to supply you with a new adapter.
Yeah.
Yep. Excellent. Oh well.
Annoying.
Not that.
Thank you for organising, everybody.
Yeah.
I'm signing off now.
Thanks very much,
See you
Mark.
again.
Appreciate it.
Bye.
Thanks for coming. Thank you.
All right. Bye.
Thanks very
Bye.
much.
Bye.
Cheers.
I think I'm going to do the same, as this is not the best quality in the world. I'll see you later.
No worries. See you in a bit.
See ya.
Yeah.
I'm going to make a move as well. Thanks for everything.
Yeah.
Yeah, no worries. Thanks very much.
Cheers. Bye.
Cheers.
Yeah. Cheers, and Pete.
Thanks very much. Yeah, and we're all fading, so I'm going to disappear as well, which means that everybody is. So
When Magnus goes to sleep, everyone goes to sleep.
well remembered. Nice. You have to be a certain age, I think.
All right.
Nice.
Cheers, and Pete.
Yeah, thanks for coming, Steve. Nice to see
See you
you.
then. Bye.
See you later.